Let me turn the thing over to Evgeni. It's a real opportunity for us to have Evgeni here. Evgeni is a senior director from Qualcomm AI Research. He's obviously he's been driving something what we call as a TinyML summit with Pete. Both Pete and Evgeni actually created a massive amount of momentum in the industry by bringing all different companies together and creating a cohort of people who believe TinyML. And that's sort of like where, the academic side is something that kind of rolled out of me observing this and kind of seeing like, wow, there's a massive amount of opportunity here. We invited Evgeni to kind of kick off what is TinyML. So he's going to talk about the massive opportunity when machine learning meets the real billions of sensors that we have today. Pete, would you like to add anything about Evgeni?
No, I mean, he's really been the driving force behind, TinyML and the TinyML Summit, as well as being one of the first people who actually inspired me to think about tiny machine learning, thanks to his work on the glance sensor. That was one of, when I saw him presenting that at Google, that was one of the aha moments of like, wow, you can actually do machine learning in this tiny little sensor that only uses like a milliwatt of power, and you can actually recognize faces and do all this other sort of really cool stuff. So he's really part of the reason I'm here. So I'm excited to have him giving this talk.
Awesome. Evgeni, would you like to, I'm going to stop sharing screen, and whenever
okay. Yeah, let me.
And folks, as Evgeni has, goes about talking about stuff, if you have questions, just raise your hand, and then we can interject and then ask questions.
Let me just start it. Okay.
Well, Evgeni's bringing it up. Does anyone have any good stories?
Can you guys see it?
Oh, good. Okay. All right. We'll save your stories for later. No, we should totally make it a habit. It's like every class, there's got to be some funky story. There's got to be something going on with the whole COVID-19 craziness. So I'm looking forward to hearing this. Actually makes me feel better because I got crazy stories. And you'll often see little people walking behind me. I'm sure you'll see that over the course of the semester. All right, Evgeni. Actually, Evgeni, what we're seeing is your presenter screen.
Okay.
Not the presentation.
Oh, not the presentation. I see the presentation. Can you see the presentation now?
Yeah, we can see the presentation, but we're seeing the presenter view.
Yeah, I believe there's a way to switch it.
I think if you go to display settings, I think it allows you to quickly switch, right? Up on top.
Okay, let me do it then.
It's times like this, I often like to say, it's like, how many PhDs we have on the call? We'll figure this one out. We got this. Tim, do you have a question? Oh.
So Vijay, in terms of leading by example, you should probably start with your story.
Start my, oh, okay, well, there Evgeni goes.
Can you guys see it now? Not yet?
Now we see the PowerPoint. So if you go into presentation mode.
Are we good?
No, we still just see, yeah, it's switching. Nope, we still see the presenter view.
Display settings.
Yeah, I wonder if you go to, yeah, swap that, yeah, or duplicate, yeah.
How about now?
Yeah, perfect. All right.
Awesome. Okay. Well, good morning, everyone, and hello from the Bay Area. My name is Evgeni Gousev, and thank you, Pete, for the introduction, and Vijay. Yeah, I think the TinyML ride has been a lot of fun, and hopefully we'll inspire another 50, 100,000 people today to join this community. It's really fast-growing community. A lot of interesting technology challenges, a lot of interest in innovations, a lot of interest in academic R&D problems to solve. Really a cool place and cool time to be in this community. So it's really timely, because I think what we see happening in the field, we see a lot of technologies and approaches and tools coming to support this massive opportunity on one hand, and we see a lot of opportunities on the application side coming, a lot of kind of new companies, new ideas coming to this field. So I think we believe very strongly that this field is going to start booming really like soon, already starting now. So it's really great, and I think when we saw this initiative by Vijay and Pete a couple months ago, it was really exciting to see that the academic community is following this and trying to develop these courses and classes and train more people to join and help to drive this opportunity forward. I think what I appreciate in particular about this class is a very strong partnership between the academia and the industry. When I saw the program, you have like a good mix of academic presentations and kind of from the top recognized experts in the field, but also a presentation from the industry, from people like myself, people who use TinyML to deploy it in this billion type of devices and work with end users and customers. I think that's kind of the connection that these two worlds makes it really exciting. And talking about this industry academia partnerships, in Qualcomm, like Google and other companies, we have very strong academic programs, and one of them is internship programs. So if you're interested in kind of learning more about like what we do in the industry and work with us kind of hand in hand, so I think you're very welcome to contact us. We are actually about to start our 2021 internship program now. I got some emails yesterday about like, hey, let's get the thing going. So if you're interested in doing kind of TinyML more in a real life type of environment, so you can contact me, the email there, kind of have two emails. One is my Qualcomm email, and the other one is the TinyML email, or you can connect to me on LinkedIn, and then we can get the discussion going. Again, internship is one opportunity, but if you have any questions about TinyML, if you would like to be involved in one way or the other, feel very free to contact us. I think kind of be a very open and collaborative type of community. And in Qualcomm, I think we also kind of like very collaborative, like to interact with the outside world. That's kind of how we get all these new ideas and new people. And yes, so please contact me if you're interested. So I'm going to talk kind of today. I'm going to give you a very high level overview about TinyML, just kind of to set the stage, and then you have a lot of very interesting presentations and lectures following, very specific ones. So I'll talk about like where TinyML field is today, what kind of opportunities we see ahead, and then specifically I'll talk about the vision. That's the technology that always on vision, TinyML vision. That's the technology that my team develops and commercialize in Qualcomm here. So the outline. I hope you can see my page here, second page, right? So we can, okay, good.
Yep.
So I think we'll kind of have very basic introduction of TinyML, like what TinyML is, why we do it, why we are so excited about TinyML, how is it implemented in the real world, kind of without doing the coding or the ASIC design, but like kind of give you an idea how it works. We'll talk a little bit of benchmarking, because as the field develops, I think benchmarking becomes very important, and that's the field, the area that Vijay and his colleagues drive in the MLPerf and other organizations, because that's very important as we move in kind of from 1,000 to million to billion type of devices. You want to make sure we have benchmarks, we have standards for this field to grow. I'll say a couple of words about TinyML Foundation. That's a non-profit organization. Pete, myself, and several of our colleagues started over a year ago just to drive this field forward. I'll show some examples of TinyML in different fields and for people using different sensing modalities, and then I'll talk about the technology that what we developed in Qualcomm. So what is TinyML? We all live in the physical world. So kind of on the left, you see the physical world with my dog there, enjoying the physical world. But yet, I think we are increasingly living in the digital world, especially today after COVID and so on. So the digital world, the analog or physical world by definition is analog. So, and how do we connect this world to the digital world? Typically, it's done through a transducer type of device that has a sensing component, that has an analog to digital converter component, and then you have some kind of microcontroller who does some kind of analytics there. And then as an output of this device, you see a bunch of ones and zeros, and then this goes to the edge AI or cloud AI. And you get all the analytics there. That's kind of a typical pipeline for this physical to digital world connection and AI today. And it works okay, but it has several fundamental issues. So one, it's very energy inefficient because you need to transfer a lot of ones and zeros, and you need to digest them. So that's very inefficient. It works again on the cloud, but the energy consumption is enormous. I think there is some research that was done at MIT and other schools saying how much energy it consumes to train a model. So it's actually very environmentally unfriendly. The carbon footprint of AI today is actually embarrassing. If you look at these numbers, people are so excited about TinyML. People are building a lot of cloud stations, cloud farms, and it consumes tons of energy. So I think that's definitely not a scalable way to go there. It has privacy issues because when you transfer this data, the data can be intercepted at any point, and there are obviously some concerns there. To transfer the data from the physical world to the cloud world, it takes time, so there are latency issues. And what happens if your network is down, if your Wi-Fi is down, if your LTE is down? So you cannot do much intelligence in this case. So that's kind of intrinsically and fundamentally today the cloud-based AI has some of these issues there. So that's where TinyML comes to play and comes to shine. So basically, TinyML, it enables machine intelligence right at the boundary of the physical and digital world. So it's a set of technologies, hardware, software, tools, algorithms, everything, networks that allow to do machine analytics right at this boundary between the physical world and the analog world. It could be on the digital side, it could be on the analog side. I mean, different people, different companies use different approaches. There is analog compute, there is the digital compute, compute in memory, and so on. But again, the key, it's really you do data analytics, you do machine intelligence right there. You don't transfer this data. And kind of obviously it has a lot of advantages compared to the traditional AI today. It's most energy efficient because you don't transfer tons of ones and zeros, you just do a little bit of bits here and there. The output of this TinyML engine is metadata. You don't send tons of images, you just send your digested information there. It's very fast because, again, you compute where the information is, and you're not relying on connectivity here. So again, fundamentally, TinyML is the way to go. And if you're talking about billions of sensing devices deployed everywhere, like you want to sense anything in environment, your car, everything. So you really want to do this kind of analytics right there without getting cloud involved. So again, fundamentally, TinyML is the way to go. And as we live more and more in the digital world, we need to have more TinyML really to digest this information and make it meaningful in a very energy efficient way, because again, otherwise it's not really scalable. It comes with a price. It's not easy to develop TinyML. First of all, this type of tiny devices, they don't have much energy capacity there. I think at best, you have a small coin cell battery, maybe tens, hundreds milliamps hours battery. And typically the requirements for those devices, it has to last for years. I mean, at some point, people will probably develop energy harvesting type of applications. I mean, today, energy harvesting is not very efficient yet, but you really need to design your system in such a way it doesn't consume tons of power and it can operate for like years on this very, very tiny battery. Second, you don't really have GPUs on these tiny devices to be able to run machine learning there. Typically, you have a microprocessor, like ARM type of microprocessor or other type of microprocessor. Typically, you have tens to hundreds of microhertz type of clock speed there. And you really need to run this complicated machine learning at this pretty small device. By the way, I think when you think about this, 100 megahertz is not really bad. When I was at school about what 25 years ago, we were talking about like the state-of-the-art Pentium machines. They were like 60 megahertz, like huge desktops. And now this 100 megahertz you can run on a tiny piece of silicon. That's kind of when you think about this scale, and that happened over like what 20 years. Then you can run it. We kind of tend to forget about this type of things, but if you look at the perspective, that's kind of an enormous progress there. But the point here is you really need to design your system in such a way to be able to run all the compute in these very, very small horsepower type of devices. Memory is another big requirement there because machine learning in general is very memory heavy type of technology. You really need to have a lot of memory to store your data. You need to have a lot of memory to store your model, weights, and so on. So this type of devices, they don't have tons of memory. Very often it's less than, typically it's less than 1 megabyte of memory, often like in the tens of hundreds of kilobytes. So that's another big constraint there. And it has to be low cost because if you're thinking about billions and trillions type of devices, it has to be low cost to enable this massive deployment. And this actually what these four constraints that makes this field very interesting and on one hand challenging but very exciting from the technology perspective, because to be able to develop such devices you really need to think really smart and innovate in all of these areas. So the way we define TinyML kind of very broadly, it's a set of machine learning architectures, techniques, tools, approaches, everything basically end-to-end that capable of doing on-device analytics for a variety of sensing modalities. I'm going to talk about vision a little bit today. I think Vijay mentioned audio. It is already widely deployed. Motion, chemical sensing, environmental sensing, health-related sensing, all kind of sensing there. But the key there is that this type of devices, they have to consume less than 1 milliwatt of power, 1 milliwatt or below. Again, when we talked about this a couple of years ago, it sounded like more like a science fiction, but it's real. You see a lot of devices already kind of in production and deployed at this extremely low power. So that's again the way to go compared to traditional ML that consumes like watts or megawatts type of power. We're talking about milliwatts here. Why are we so excited about TinyML? I think that's kind of what Vijay also briefly mentioned earlier. So it's all about data. I mean, if we all think that data is a new oil, a new electricity, as some machine learning experts say, so ML is really like a tool to dig this oil out. And if you look at the data distribution at these different levels, cloud, edge, and tiny, about 1% of the data, only 1% of the data is on the cloud. So that's very small, and yet kind of companies like Amazon, Google, Microsoft, they make tons of money just by using this 1% of data. So then moving down to smartphones, it's about 4% of the data there. And the data comes from people sharing pictures, doing audio, clicks, GPS-based location data. And you can think about tons of applications and machine learning applications people develop using just this 4% of the data. But moving down to the kind of to the physical world, there's like 95% of the data is there. So, and then kind of you can turn your imagination and think like how much you can do with this 95% of the data if you can make it meaningful, digestible, and use it for people's need and for other type of applications. So I think that's why, again, we are very bullish about this, because you can think about new applications, new startup, new ideas. Is like 95% is still uncovered compared to the 1% that, or few percent that what people use today. And this data comes from, as I said earlier, from a variety of different modalities. You have vision, CMOS cameras, infrared cameras, you have motion type of sensors. IMU stands for inertia measurement unit. It's accelerometer gyros, audio, environmental, temperature, optical sensors, and so on, all kind of different sensors. And typically, TinyML use neural net light type of models like CNN micro. And in terms of hardware, the typical configuration is an MCU with some kind of hardware acceleration, which is we'll talk about this later, which is typical these days. But again, the take-home message here on this slide: tons of opportunities, and it's simply based on the amount of data that is available today. It's going to become available more and more in the future as people deploy more sensors, companies deploy more sensors, more use cases, more need, like for all kind of things. Like one example, in California today, we have a lot of like wildfires, and it's getting worse and worse every year. So if you deploy this type of sensors in the forest and you get real time of data about all this fire starting, you can really be very efficient in operation. You can save people lives, you can save houses, property, tons of money, environment. So a lot of opportunities there, what people don't use today yet. Yeah, and if you look at kind of the fields where TinyML is already deployed or is about to be deployed, it's literally everywhere. So you see TinyML applications in healthcare, automotive applications, wearables, AR, XR, VR, AR is going to be big applications, appliances, in industrial IoT, security cameras, phones, smart cities. So basically, if you look around and kind of see what happens around you, there is every single place you can use, like in this room where I'm today, I can use probably like a dozen of TinyML devices just to do things here. So again, it's literally everywhere, and it's a massive opportunity. I think we think about like billions, trillions of devices, and all of this will have this TinyML engine that will collect this information and digest it. So what drives this rapid development in the past 2-3 years? There are several vectors there. One is the hardware becomes more and more energy efficient, and it's driven by new technology nodes, new architectures, hardware acceleration used, and kind of in general, this field becoming more and more mature. That's one. Second, starting from CNNs, what about 7-8 years ago, the networks and algorithms becoming more efficient, more sophisticated, and that drives a lot of opportunities there as well. We see a lot of investment in like big companies like Google and so on into the development infrastructure and software tools for this. This is also extremely important for this. I think you're going to learn more about TensorFlow Lite. That's kind of one of the tools that Pete and his team pioneered and kind of deploy also very widely now. So that helps people to develop their own applications. and there are also small companies developing this as well. So what is important is the ecosystem really is diverse in many ways. So you see different applications, different fields. You have hardware, software, application, business people, supply chain people. So and the diversity of this ecosystem is really an indication on one hand, and also kind of that this field is successful. You see more applications coming. You see more investment into the field. there is more startup activities, more M&A activities. A couple of companies acquired by big companies in the past months in TinyML. So it's really kind of a lot of things happen in this field, and it helps it to drive very quickly. I think as a way to kind of to help and to promote this ecosystem, several of us we decided that we should have some kind of organization that will help to drive this and ecosystem. And that's how this idea about TinyML Foundation came. As I said, it's still pretty young. It's a little bit over in a year, but it's already a kind of a big global community there. So you see a snapshot of TinyML groups all over the world, but 3,500 people there already, and it grows really fast. So you can join those. And I think I'm also pleased to announce that as of yesterday, we started a group in Boston, and this group already has 45 members. So I think overnight, 45 members joined this group. Again, you see like a lot of interest in this area. So Vijay is a co-organizer there. So there will be a lot of activities in this group. In fact, there are 2 already presentations planned for next week. So you can go and join meetups or join LinkedIn for TinyML, and you see all this information there. So by design, this community is a non-profit organization, and it's open source type of organization. So I think what we want to do to connect people all over the world, to share all this knowledge, share all these opportunities, and all this information is available on the TinyML website immediately almost, and people can use this information. They can use these platforms to collaborate. So again, the whole idea there is really how do we accelerate TinyML development there. And talking about the foundation and the TinyML activities, there are quite a few of them. So we started from the summits in the 19. So next March is going to be our 3rd summit. This is kind of the flagship event. And next year at the summit, we're also going to have a research symposium specifically designed and developed for the academic community to present papers and share the results in TinyML. So I think Vijay and Boris Mormon from Stanford, they are 2 co-chairs of this symposium. And I think the call for papers went out a couple of weeks ago. I think deadline is in November. So that's one flagship event. So we're doing the TinyML in Asia. It's going to be virtual in a couple of months. So very strong program there where the supply chain is. We were planning to do one in Europe this July, and due to the COVID, it got moved to next year. As I show, we have meetups. So what we do in meetups today during these virtual days, every other week we have webcasts, typically given by 2 presentations. We had one this week, and we'll be having like 2 next week and 2 the week after. So these presentations are typically given by experts in the field, or startup companies, or big companies, or people from the academia, really focused on TinyML, and all of this is distributed on the YouTube channel. So if you have very specific interest in a very specific topic in TinyML, you can go there and learn this in great depth, and you can connect to these people as well. So if you want to get involved, the tinyml.org is the way to your first stop. And again, you can contact me, you can contact Pete, you can contact Vijay if you want to learn more, or if you want to get involved.
One thing I just want to mention here on that notion is sort of given this ecosystem, there are a couple of interesting things that we want to do. One is like, as you do your projects, for instance, Kobe had a great idea about actually getting some of your projects can be, featured on TinyML stuff. Like, imagine if we have the Boston meetup, and then interesting projects that come out of the class can actually be featured there as a talk. We were thinking of doing that, like sort of a cohort of like, these are all the interesting projects. And of course, like as Evgeni just mentioned, there's a research summit that's created. That's towards the end in November. So if you're doing research and you want to publish, this is a new area that sort of is at the intersection of different fields. So it's a flagship summit if you look at the program committee for the graduate students especially. Just wanted to mention that.
Yeah, and just to add to this, that's a very good point, Vijay. Just to give you an example, about a month ago, we had a presentation at the TinyML talks given by 2 students from Harvey Mudd. They just graduated for Harvey Mudd, and they had an intern project with Sentient, a startup company in the Irvine area. So basically, they use Sentient hardware to develop application, and they share this experience to the global community. And now it's been viewed like by a few hundred people, and it's a great exposure to the students, great exposure to the community. And now it's on TinyML. You can go and check it there. So definitely, we would like kind of again to be as diverse as possible. So these presentations are given often by like CTO, CEO type of companies, but then it's given also by graduate students or undergraduate students. Again, have this huge diversity in this ecosystem. Okay, and switching gears now, how are we doing this time, Vijay? We have until 9, until what, noon your time?
No, actually 10 minutes, 11:45 is when we wrap up.
Oh, okay. Well, let me speed up then. How TinyML is implemented. So I think what is the key here, and that's what we learn, and that's what it makes it feel, this field very, very interesting, is you really have to be aware, and you have to be of all the 3 key components: hardware, algorithms, and software. And you really need to innovate and know all the 3 pieces. And when the 3 pieces come together, then you see a lot of interesting thing happens. And you also need to optimize and innovate in all of these 3 areas. So specifically, if you talk about like where TinyML is today, so it's already kind of good enough for many applications today. We see, as I mentioned earlier, a lot of hardware, good hardware from big and small companies with digital acceleration. In the algorithms area, people develop new tools, new techniques like quantization, compression, and pruning, and they'll be able to develop smaller models down to like hundreds of kilobytes. And then you see initial tiny application that already creates some money, already creates some value there. What do we see coming in the next year or so, and actually already happening now? There are more innovations in the hardware space. There is like some techniques I mentioned: compute and memory, analog compute, neuromorphic compute, and so on. The models are becoming smaller, like down to tens of kilobytes. You can deploy those, and you see more and more application coming simply because just people are becoming more and more aware and value creation. Really excited. And on top of this, a lot of new enabling technologies coming from the other partners of the ecosystem: ultra low power sensors, novel memories, 3D stacking, energy scavenging, ultra low power radios, and so on. So it's really all these pieces are coming together. It's actually a great time to be there. I'll probably skip benchmarking. So, sorry,
one thing to emphasize on the previous slide is the key thing that Evgeni mentioned is this. You've all sort of heard about the models and whatnot. And these models today, for instance, are in the order of megabytes or gigabytes. I mean, they're pretty big models, right? That you're typically dealing with. What you will realize as you kind of go through is we're dealing with extremely small, like it's not about how big you make the model, like GPT-3, someone was talking about it, it's 175 billion parameters or something. It's enormous, right? Instead of going big, what we're doing is like, how small can we go and try and make it intelligent? So it's actually flipping the whole thing, and it actually requires you to think differently. So when we get into the ML algorithm space and so forth, that's where the twist kind of happens, is we start thinking, how can we actually make this smaller? Just wanted to chime in because that's a key takeaway here. And most of what Evgeni is mentioning here are the things that we will go deeper into. So this is, it's nice that he's got this intersection, because there's aspects of focusing individually, but then there are aspects that intersect across these different domains as well. So thanks, Evgeni. Yeah, please go on.
Yeah, so we'll keep the benchmarking. I think where we are now today, I think we're building awareness and kind of some initial products, but I think in about 3 to 5 years, we're going to see tons of killer applications, and will be an explosive growth there. I think that's, again, a great time for people from the academia, students to join this community. A lot of growth here. Let me talk about the application. That's kind of the fun part. So let's start with the audio. So here I show a couple of applications. One is from Sentient, that's a company here in the Irvine area. So what they do, They develop a very simple, that's a hardware company, but they also have algorithms. They develop hardware, you can see a very small 1.4 by 1.8 millimeter, that's the generation 1. And what they do, they have like a simple 4-layer network, neural network, but this network allows them to do a lot of audio applications like keyword detection and so on. But what is remarkable, this is done at extremely low power, not even like milliwatts, microwatts. So you can think about like Alexa that is always on, and then a lot of applications. This company just shipped over 1 million devices already, a startup company, very successful. They raised 40 million in the second round. But the point here, again, very simple network, very cool application, and low power. And another company, AON Devices, they develop also some specialized hardware and to be that can run RNN, DNA, and another type of networks. Quite small, but again, a lot of applications, a lot of opportunities there. Again, microwatts type of, microamps type of range. So this is interesting. That's kind of where I get very excited when I see big sensor companies like Bosch. Bosch ships like millions of sensors every day. So if you can think that the CEO are talking about this machine intelligence, and I think the point there is companies like Bosch, they want to see AI inside of the sensor itself. So on one hand, again, we have Google type of companies developing these tools, and then on the other hand, you have this sensor type of companies that kind of do the same things. And again, this is going to be explosives. Some examples from Bosch. So here on the upper left, you see the super analog device, which is a diaper. But if you add a couple of sensors in this analog device, you can really make it smart, and you can see what is the state of the diaper. Is it being dirty, wet, and so on. You can do it again. The other one on the bottom right, that's kind of the one I already mentioned. If you deploy sensors, temperature, pressure, humidity sensors everywhere, then you can do a lot of useful things like risk management, early fire prevention, and so on. Another example, that's a very, very interesting example too in the industrial IoT. So if you deploy IMUs and attach them to a motor, for example, in the industrial environment, and you can kind of do machine learning on this engine, and you can use it for a lot of applications like failures, predictive maintenance, and you can save a lot of money. You can save kind of do a lot of interesting applications there as well. I think we have, how much time we have? About 3 minutes. So very, very briefly, this is the technology and the product that my team develops in Qualcomm, and we are super bullish about this. That's always on vision. So you see this device here on the bottom. That's so that's the TinyML vision device, and I think I have it here. I'm not sure you can see it. It's like really like a couple of millimeters by a couple of millimeters. So what this thing is, it's a camera, it's a lens there, and it has a processor there, small processor there, shown here on the left, that can run analytics all on this device. Again, typically you just take a picture from your webcam or whatever you send, or from your phone, send it to the cloud, and you do analytics here. So in this case, you don't do anything like this here. So you just do all machine learning there, and you do information there. A couple of kind of a lot of applications, because it can be used basically everywhere: smartphones, watches, tablets, VR, and so on. And just give you some examples. So we use this type of tiny device, and you see like real images from this device to do human detection, face detection. You can do retail type of application, gestures, logos, and so on. I mean, you see this type of things, bounded boxes, in many CV computer vision applications. But again, what is cool here, you can do it not at watts type of power, at milliwatt of power in this small form factor. Again, that's an example where TinyML comes and it shines, and it also does it in a privacy type of fashion, because you don't send images out of this device. You just send a bounded box. I see like 2 people in the room, and you can deploy these devices again everywhere where you don't usually use cameras, like in a bedroom or bathroom or any public places. Hotel room, like if there is a fire in the hotel, you will know like what rooms are occupied without interfering with people privacy there. So it's a lot of applications, but again, the key there is how do you do machine intelligence at this small TinyML form factor. And it's like what Vijay said earlier, it's a very different mindset to be able to develop this type of systems, because traditionally when you do computer vision, you just take a pretty image, send it to the cloud, and you don't worry about things. GPUs will take care of the rest. To be able to do this at 1 milliwatt, you really need to look at all kinds of things differently. And the first kind of difference there, that you're not going after pretty images, you're going after information. You don't need high resolution, you don't need color, you don't need 32 bits and so on. You can get a lot of information, just like what the human nature teaches us to do. Like humans, we don't have billions of pixels, or even like other creatures in the world, they don't have this type of things. So you really need to innovate and think about the thing on one hand holistically, but also, again, the mindset is different, and you really, and you need to count every penny everywhere. I'm going to skip this. This is the product, as I showed earlier. We have actually two products already on the market, and it's really getting a lot of interest from customers. Just to summarize, I hope I try to inspire you, because we are all very excited about this. Pete, myself, Vijay, and the whole TinyML community about the opportunity in TinyML. So TinyML is set of machine learning technology at the very edge of the physical world, and they do this machine intelligence. It's extremely low power. Why TinyML now and in the future? Because it's all about data and analytics at the edge, and basically everywhere in all verticals. And to be able to implement it, you really need to look at things holistically: hardware, system, software, do a lot of design, do a lot of optimization there. And when? It's now. I mean, again, you see a lot of applications, a lot of startups, a lot of activities in the academia. But it's really a great time to be. And thank you, Vijay and Pete, for putting this class together. And I hope you guys are going to learn a lot of interesting things about this. And as you learn, you're going to see a lot of kind of development in the industry, in the whole ecosystem in TinyML. So again, please keep an eye on tinyml.org and like what happens in the field there. But it's growing, it's booming very, very fast.